Hello, good morning, or good afternoon. I'm back. We're going to talk more trig today. So last week in our videos, we talked about trig ratios, and I gave you guys this handy little nonsense phrase that we call SOHCAHTOA. And this helps us remember our three trig ratios, that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The very last example I did last week was an example where we solved for a missing angle. And to do this, we used something called inverse trig. And I want to pick up right there because we just did the one example. There were a couple examples in your practice problems if you did those. But we're going to see inverse trig show up a little bit more. So I want to do just two more examples of how we use inverse trig to solve for missing angles instead of missing sides. If you'd like a copy of this handout that I'm using to follow along, you can print that out. I did attach it to the post with this video. Otherwise, you can just watch along here and watch me demonstrate these two problems. All right, so here we have a right triangle. We have two sides, but we do not have any of the angles. So we're going to solve for both of these missing angles, and I'm going to call this one x and we'll call this one y. And the first thing we need to do is just decide, where do I want to start? Which angle do I want to find first? So maybe we want to do angle y over here. That means we're going to stand at point S, or orient ourselves at point S. I didn't use this phrase last week, but this is actually called the reference angle. So it's where we're orienting ourselves to solve this trig problem. Now, the next thing is to decide what are my two sides I'm working with. Well, I have this side. It's right next to me. This is the adjacent side. And I have this side right here, which is the longest side of the right triangle, of course, the hypotenuse. So I'm working with the hypotenuse, the adjacent side. So I look back at SOHCAHTOA, which of my trig ratios uses adjacent and hypotenuse? Aha, must be cosine. Cosine is adjacent over hypotenuse. Now I can write my equation. So I come back down here and I say the cosine of this angle, which is y, the cosine of angle y, is equal to adjacent, which is 5, over hypotenuse, which is 13. Now remember that in this case, we know the ratio, but we do not know the angle. So at this point, it's a calculator problem. We're going to end up using the buttons on our calculator called inverse trig buttons. So last week we talked about sine, cosine, and tangent. The second function here is inverse sine, inverse cosine, and inverse tangent. And when we know the ratio, but we do not know the angle, that means we're going to use the inverse button. So on my calculator, I'm going to type inverse cosine, and I'm going to plug in the ratio, 5 over 13, and this will give me my angle measurement, about 67.4. Okay, so now we have angle y. Now I could use trig again to find angle x, but I don't need to, right? Because we have two angles of this triangle, so we could just subtract them from 180 and we'll get our last missing angle there. So 180 minus the 90 minus the 67.4. And now we have angle x, which is about 22.6 degrees. Okay. One more example here. We're going to start this the same way. I've got two sides. It's a right triangle. We're going to solve for the two missing angles here. So again, I'll call this one x and call this one y. We can choose either one to start with. Why don't we do x first this time? So I'll kind of be standing over here. In other words, point O is my reference angle. And so what two sides am I working with? Well, I've got the adjacent side right here. And across from me here, this is the opposite side. So adjacent and opposite. So looking at SOHCAHTOA, which of my trig ratios uses opposite and adjacent? There it is, tangent. Now I can write my equation. So the tangent of angle x is equal to opposite over adjacent. Once again, we have the ratio. We don't have the angle. I'm going to grab my calculator and I'm going to use the inverse tangent button, and I'm going to plug in that ratio, and it will output my angle. So x is approximately 73.74 degrees. And just like before, now if I want to find the third and final angle, we can just subtract all these angles from 180. And now I know that y is about 16.26. Okay. So now that we're comfortable using inverse trig, we could see this pop up in a story problem. Here's a quick example. I've got a 32-foot telephone pole, and it has a 70-foot support cable attached to the top of the pole. What angle does the support cable make with the ground? What angle does it make with the pole? Okay, so we can assume the pole is perpendicular to the ground. Notice we have a very similar picture here as we did above. I have a couple sides, but I don't know these angles. So we can choose which one to start with. Maybe I'll start with x right here. This will be my reference angle. So I have the opposite side. I have the hypotenuse. Opposite and hypotenuse, that's going to be the sine ratio. So we will say the sine of angle x is equal to opposite over hypotenuse. And now, once again, we have the ratio. We don't have the angle. We're going to grab the calculator. We're going to use inverse sine 32 over 70. This gives me an angle of about 27.2 degrees. And if I want to find that other angle now, I can, of course, subtract everything from 180. And we get about 62.8 degrees. Okay. On the back side of this handout are two more story problems. Now, these two problems are going to use phrases angle of elevation and angle of depression. And I want to talk about that. I know we had a few story problems in last week's assignment, but none of them used these phrases. And these are phrases that are commonly misinterpreted. So let's talk about how to draw these diagrams correctly. All right, so we've got a rescue worker located 175 feet above the ground in a lighthouse. He spots a ship on the water at an angle of depression of 62 degrees. How far from the base of the lighthouse is the ship? Let's draw a picture. So, we've got the shore. Here's our lighthouse. Here's the water. Here's our ship. Okay. The rescue worker is 175 feet above the ground. Okay, so that's the height of my lighthouse. He spots a ship on the water at an angle of depression of 62 degrees. So, what we're saying here is that this person has a line of sight to the ship, and we can show their line of sight with like a dashed line like this. So that's their line of sight. Notice that the line of sight with the lighthouse and the water makes a right triangle. The angle of depression is 62 degrees. Here's the mistake that people always make. If the angle of depression is 62, a lot of people want to put the 62 right there. That's actually incorrect. When we talk about angle of depression or angle of elevation, we're always talking about from the horizontal. So if this person is standing here, their horizontal line of sight from where they are would be like this. The angle of depression goes from that horizontal and down. So the 62 degrees is actually right here, which means that we can fill in this other angle here because these two angles together make a right angle. So subtracting 62 from 90 would give me an angle right here of 28 degrees. And if that's 28 and this is 90, then this angle down here would be 62 degrees again. Now we have enough information to solve this problem. The question is, how far from the base of the lighthouse is the ship? So that would be here. So I'm going to choose an angle to work with. Maybe I'll use the 62 over here. And if I'm using 62 as my reference angle, I have the opposite side, which is 175, and the adjacent side is what I'm solving for. Opposite and adjacent. If we reference SOHCAHTOA, opposite and adjacent is tangent. So we can say the tangent of 62 degrees is equal to the opposite side over the adjacent side. And now we do have an angle, but we don't have the ratio filled in. So we are going to have to use some algebra here to solve for x. So remember, this is being divided by x. So to undo that, I'm going to multiply both sides by x. And these x's would cancel, and I get x times the tangent of 62 is equal to 175. And remember, tangent of 62, this is just some number. So if that's being multiplied with x, I'm going to divide this side by the tangent of 62, which means I need to divide this side by the tangent of 62. And I get x is equal to 175 divided by the tangent of 62. And now this becomes a calculator problem. So let's grab my calculator and let's do this. 175 divided by the tangent of 62. X is approximately 93.05. And that would be feet. Okay, so that was angle of depression. Let's look at one that uses the phrase angle of elevation. So I am flying a kite at Gasworks Park in Seattle. I know I have let out 250 feet of string. The angle of elevation from my hand to the kite is 33 degrees. My hand is 3 feet above the ground. How high is the kite from the ground? All right, so here's me. Here's my hand. Look how happy I am. I'm flying a kite. My kite string has let way out up here. There's my kite. Okay, so here's the ground. The question is, how high is the kite from the ground? So ultimately, we're going to be figuring out that distance. Notice we get a right triangle here. Two key things. The angle of elevation from my hand to the kite is 33 degrees. My hand is right here. Remember we said that an angle of elevation or depression is always from the horizontal. So at this point, from the horizontal, the angle is 33 degrees. My hand is 3 feet from the ground, so the distance here is 3 feet from the ground. If this is 3 feet from the ground, this little distance right here is also 3 feet from the ground. So notice what I'm doing now is I'm actually using this triangle as kind of inside our diagram, and I'm going to solve for this distance right here, x. And whatever I get for x, after I get that value, I need to add on this 3 so that I can answer the question, which is high up off the ground. How high up off the ground is that kite? Let's see, the last piece of info I didn't fill in here is that the string is 250 feet long. Okay, notice we have a trig problem here because I have an angle, I have a side, and I have a missing side, and it's a right triangle. So if I'm at the 33-degree angle, this is the opposite side, this is the hypotenuse. Opposite and hypotenuse is going to be the sine ratio. So I'm going to say the sine of 33 degrees is equal to opposite over hypotenuse. I'm going to solve for x by multiplying both sides by 250. And now that I've solved for x, I'm going to grab the calculator. I'm going to do 250 times the sine of 33. And I get x is approximately 136.16 feet. Now, it feels like we're done, but we're not quite done. We just found the distance from the kite to here. We now need to tack on this extra 3 feet to account for the height of my hand. So take your final answer, or not your final answer yet, but your answer for x, and we're going to add 3 onto this. Now my final answer is 139.16 feet. Okay, I hope that video is helpful for you guys. I have attached some practice problems. There's a handout with an answer key, so try those. When you're feeling confident and comfortable, go on to the learning check, the required piece for this week, and see how you do on that little learning check quiz. All right, everybody, stay safe, stay happy, and until next time, have a great week.